Consider Venus, almost the same size and mass as Earth. It's often called our sister planet, but this analogy is a deadly deception. Ironically, the planet named after the Roman goddess of love and beauty was aptly described by Carl Sagan as a hellish place. If you were to step onto its surface, even in the most advanced spacesuit, your death wouldn't just be swift, it would be absolute and instantaneous. You wouldn't be burned. First, you'd be crushed by pressure equivalent to a kilometer of water. Then you'd be incinerated by temperatures hot enough to melt lead. Finally, any remains would dissolve in sulfuric acid rain. How did a planet so similar to ours become such a true hell? For centuries, Venus kept its secrets hidden beneath an impenetrable cloud cover. Early astronomers saw only a bright point in the sky, while science fiction writers dreamed of humid tropical jungles and exotic civilizations beneath that veil. Think of Ray Bradbury, who in his story, All Summer in a Day, described Venus as a world of perpetual rain, or Edgar Rice Burroughs with his oceans and flying cities. The similarities in size and gravity only fueled these hopes. We looked at Venus and wanted to see a second Earth, overlooking the ominous hints of its true nature. Romantic dreams began to crumble in the mid-20th century with the advent of radio astronomy. Initial measurements revealed that Venus's surface temperature wasn't just high, it was monstrous, hundreds of degrees Celsius. The final verdict came with the American Mariner 2 mission in 1962. Flying past the planet, the probe confirmed a surface temperature of approximately 425 degrees Celsius. 197 degrees Fahrenheit. This was so unbelievable that many scientists initially dismissed it as an instrument error. But data continued to pour in, and each new discovery painted an increasingly grim picture. Another oddity of Venus is its rotation. It's the slowest rotation in the solar system. A single Venusian day lasts 243 Earth days, which is longer than its year, lasting 225 Earth days. It rotates so slowly and in the opposite direction that the sun rises in the west there. This isn't just an exotic fact. The lack of rapid rotation, and consequently a weak magnetic field, deprived the planet of protection from the solar wind, which for billions of years stripped away light elements like hydrogen from its atmosphere, leaving only heavy, suffocating gases. But what exactly are these heavy, suffocating gases? Imagine the weight of a car pressing down on every square centimeter of your body. This is not a metaphor. The atmospheric pressure on Venus's surface is 92 times that of Earth, equivalent to diving 900 meters, about 3,000 feet, underwater. Most military submarines would be crushed like tin cans at such a depth. This isn't just dense air, it's essentially a supercritical ocean of carbon dioxide, an environment that would sooner crush you than allow you to breathe. If the pressure didn't instantly destroy you, the temperature would. The average surface temperature is 462 degrees Celsius, 164 degrees Fahrenheit. That's hotter than a pizza oven and enough to melt lead. The paradox is that Venus is hotter than Mercury, even though it's almost twice as far from the sun. The entire reason lies in its atmosphere, a blanket that transformed the planet into a hothouse. No existing cooling system could cope with such a heat flux. The laws of thermodynamics are relentless. You wouldn't just burn, you'd boil alive inside your spacesuit in fractions of a second before the suit itself began to melt. The chemical composition of the atmosphere completes the picture. It's 96.5% carbon dioxide. But higher up in the clouds, a constant haze of concentrated sulfuric acid droplets floats, comparable in corrosiveness to car battery acid. On Earth, acid rain is an environmental problem. On Venus, it's normal weather. These rains, while evaporating before reaching the scorching surface, permeate the atmosphere itself, and sulfur compounds give the air an unbearable smell of rotten eggs. And if some miracle allowed you to survive and look around, you would see nothing but an orange, oppressive haze. The dense atmosphere scatters light so intensely that everything is submerged in a murky amber glow. Soviet probes revealed that visibility is only a few kilometers, a couple of miles. The horizon is blurred, the sky is never blue, and a light breeze feels less like a gust and more like a shockwave. You would stand on cracked, scorching rock, gazing at a landscape that hasn't seen direct sunlight in thousands of years. But the main element missing from this picture is water. Venus is virtually bone dry. Its atmosphere is roughly 100 times drier than the air in Chile's Atacama Desert, the driest place on Earth. If all of Venus's water were gathered, it would cover the planet with a layer just 3 centimeters, about an inch deep. For comparison, Earth's oceans would create a layer 3 kilometers, nearly 2 miles, deep. And this complete absence of water is perhaps the main key to understanding its tragic history. But how did we learn all these details? Not from telescopes. We learned it because we sent our scouts there, robots. During the height of the space race, the Soviet Union undertook an almost impossible task: to land on Venus. Engineers faced a challenge similar to designing a craft to descend into an active underwater volcano. To withstand this unimaginable pressure, landers were built like bathyscaphs, nearly perfect spheres made of the strongest titanium alloys, without windows and with minimal openings. These were true fortresses with powerful thermal insulation and cooling systems designed to survive for at least an hour. The first Venera series probes perished without even reaching the surface. They were either crushed by pressure during descent, or their electronics failed due to overheating. A notable example is Venera 4 in 1967. It was designed to withstand 25 Earth atmospheres of pressure, which engineers believed was a huge margin of safety. It was crushed at an altitude of 25 kilometers, about 15.5 miles, never reaching its target. Each mission was a harsh lesson, revealing how severely we underestimated this world. Venus mercilessly destroyed one Earth messenger after another. The breakthrough came in 1970. Venera 7 achieved a historic feat. It became the first probe to transmit data from the surface of another planet. The probe miraculously survived. After a harsh landing, it transmitted a very weak signal, which scientists on Earth painstakingly extracted from the noise. It lasted only 23 minutes before falling silent forever, but in those minutes, it confirmed the numbers: a temperature of 475 degrees Celsius, 887 degrees, and a pressure of 90 atmospheres. Humanity had direct proof. The pinnacle of the program was Venera 9 and Venera 13, which transmitted the only panoramic images ever taken from the surface. To capture these photos, engineers had to employ a clever trick. Robust titanium lens caps were jettisoned with pyrotechnic bolts moments before imaging. These grainy, otherworldly images are our only direct view of that world. We see cracked, jagged rocks beneath an oppressive orange sky. The probes lasted just over an hour, but gave us immortal testimony. The history of the Venera program is not a story of failure. It's a story of engineering triumph in the face of insurmountable forces. In total, all the probes that successfully landed on Venus operated on its surface for only a few hours combined. This starkly demonstrates the limits of our technology. If machines made of the strongest materials survive mere minutes there, the idea of a human landing becomes pure fantasy. Venus stands as a monument to our technological humility. But has it always been this way? The story of Venus isn't about a planet born of hell. It's the story of how a world, once similar to ours, became one. About 4 billion years ago, Venus might have been very different. Simulations suggest it could have had oceans of liquid water, temperate temperatures, and a thinner atmosphere on its surface. According to some models, these favorable conditions could have lasted for up to 2 or even 3 billion years, long enough for life to originate and evolve on the planet. So what went wrong? The answer lies in its location and the relentless march of the time. As the sun aged, it grew brighter and hotter. Being 30% closer to the sun than Earth, Venus was the first to cross a critical threshold. It found itself on the wrong side of the inner edge of the habitable zone, an invisible boundary beyond which a planet receives too much solar energy to retain liquid water. Rising temperatures led to more intense evaporation of water from its oceans. This triggered a chain reaction that could no longer be stopped. Water vapor is a powerful greenhouse gas. The more water evaporated, the more heat was trapped in the atmosphere. This in turn further heated the surface and accelerated evaporation, creating a positive feedback loop. This process, known as the runaway greenhouse effect, transformed the entire planet into a giant pressure cooker. The planet began to literally boil itself until all its oceans evaporated and turned into a dense, hot atmosphere of steam. When the oceans vanished, a key geological process that regulates Earth's climate, the carbon cycle, ceased. On Earth, carbon dioxide from volcanoes dissolves in the oceans and becomes sequestered in sedimentary rocks like limestone. Scientists believe the total amount of carbon on Venus and Earth is roughly the same, but on Earth, almost all of it is safely locked away away in rocks. On Venus, stripped of water, all that carbon ended up in the atmosphere. Volcanic carbon dioxide simply accumulated over hundreds of millions of years, making the atmosphere progressively denser and hotter. Earth was fortunate. It was positioned slightly farther from the sun in the so-called Goldilocks zone, which allowed it to retain liquid oceans. Furthermore, Earth has active plate tectonics. This process constantly remixes the crust, helping to bury carbon in the mantle and regulate its atmospheric content. Venus lacks this mechanism. Its history demonstrates how delicate the balance can be that separates a habitable world from a scorching desert. So where did the acid clouds come from? As the water vanished, volcanoes continued to erupt sulfur compounds. In the upper atmosphere, under the influence of sunlight, these compounds reacted with the last remnants of water vapor, forming droplets of concentrated sulfuric acid. These clouds are not a thin haze. They form a continuous, impenetrable layer 20 to 30 kilometers, 12 to 19 miles thick, which has forever hidden the planet's surface from direct observation. This was the final touch in Venus's transformation into the world we see today. But this picture of hell is incomplete. On Venus, there exists a place with strikingly Earth-like conditions. At an altitude of 50 to 60 kilometers, 31 to 37 miles, above the surface, the pressure drops to 1 Earth atmosphere, and temperatures range comfortably from 20 to 30 degrees Celsius, 68 to 86 degrees. Add to this a gravity of 90% of Earth's, and this cloud layer becomes the most Earth-like region in the entire solar system, outside of Earth itself. This oasis exists right within the sulfuric acid clouds. This is a serious obstacle, but some scientists hypothesize that if life ever existed on Venus, it might have adapted and survived in this unique niche. This theory is fueled by dark streaks in the clouds that absorb ultraviolet light. Carl Sagan himself once proposed that these could be giant colonies of microorganisms. Microbes could potentially exist within water droplets inside the acidic clouds, using chemical reactions for energy. This remains a hypothesis, but it certainly sparks the imagination. In 2020, a group of scientists announced the detection of phosphine gas in Venus's atmosphere. On Earth, this gas is produced by microbes living in oxygen-free environments, such as swamps or animal guts. It is therefore considered a potential biosignature. The news caused a sensation, but subsequent research cast doubt on the discovery. Nevertheless, this question rekindled interest in Venus and made us wonder, are we missing something important in the clouds of the hellish planet? The idea of colonizing Venus seems insane, but not in this particular atmospheric layer. Theoretically, giant airships or entire floating cities could be constructed to drift in this temperate climate zone. Surprisingly, at such an altitude, a human wouldn't even need a spacesuit for pressure protection. Warm clothing, a breathing apparatus, and chemical protection against acid droplets would suffice. The air we breathe is lighter than Venus's carbon dioxide atmosphere, so such an airship would float like a balloon on Earth. It's a distant yet exciting prospect. The story of Venus and the questions surrounding its clouds have inspired new missions. NASA projects like Da Vinci Plus and Veritas, as well as missions from other nations, aim to finally get answers. The Da Vinci Plus mission, scheduled for the late 2020s, will drop a probe directly into the Venusian atmosphere for the first time in nearly 40 years to measure its composition with unprecedented accuracy. They will study the atmosphere, map the surface, and seek to understand how and why Earth's twin diverged onto such a radically different evolutionary path. The ultimate answer is simple. You wouldn't survive on Venus because it is the result of a planetary catastrophe. It's not merely a hot or dense world. It is the frozen in time outcome of a runaway greenhouse effect that dried its oceans, suffocated it with volcanic gases, and transformed it into an acidic furnace. If Mars is a planet we dream of terraforming, then Venus is a planet that de-terraformed itself. It is not Earth's sister, but its ghost, a vivid example of what happens when a delicate climatic balance is irrevocably broken. Death on Venus would not be an accident, but a consequence of the relentless laws of physics. The pressure of 92 atmospheres would crush you. The temperature of 462 degrees Celsius, the 64 degrees, would incinerate you. An atmosphere of carbon dioxide and sulfuric acid would poison and dissolve you. It's not a choice between different forms of death, but their simultaneous execution. Venus is a perfect killing machine, where every physical parameter is pushed to a lethal maximum, and each of these aspects is a direct consequence of its tragic history. Studying Venus is not merely an academic interest, it's a look into a mirror, reflecting one possible developmental path for an Earth-like planet. Climate scientists refer to it as the Venus warning. While Earth will never become its exact replica, we are too far from the sun for that. The physical laws of the greenhouse effect that doomed Venus are also at play here. Its history demonstrates that a planet's climate can shift from one stable, hospitable state to another, deadly one. It's an eternal and potent reminder of how fragile our own atmosphere is. Venus is the most inhospitable world in the solar system, but perhaps also the most crucial for understanding our future. The irony is that from Earth, it's the brightest and most beautiful object in the night sky after the moon, a shining evening star. This beauty is merely reflected light from the very clouds that conceal a hellish landscape beneath. Looking at its scorching surface through probe data, we must ask ourselves, do we truly appreciate the blue skies, liquid oceans, and temperate climate of our own planet? For the story of our dead twin teaches us that paradise can be lost, and sometimes forever.